Hi, I'm Elisa. And I'm Sara. And we are going to show you an experiment called the fish in the bottle.
Now I show you the materials of experiment. We use a plastic bottle with water and a plastic fish, but if you don't have a plastic fish, you can use another object with an hole like this little jar. Put the object inside the bottle with water and close the bottle with a cork. As we can see, the object floats, but if we exert a little pressure of the surface of the bottle, we can see that the object inside goes down, while when we stop exerting pressure, the little jar rises up. But how can we move the fish without touching it? This experiment is possible thanks to two laws of physics relating to liquids. The first law is Pascal's principle. The pressure exerted on any surface of a liquid is transmitted with the same value on any other surface in contact with the liquid. Instead, the second law is Archimedes' principle. A body immersed in a liquid is subject to an upward-facing force, called Archimedes' thrust, of an intensity equal to the weight of the volume of the liquid move.
According to the law of Pascal, if we exert a pressure on the surface of the bottle, the pressure is also transmitted to the object inside it. At first, the air prevails over water in the object, and this allows it to float while remaining partially immersed in the water. The object floats because the buoyancy directed upwards is bigger than the weight of the object. We need to remember that liquids cannot be compressed, while gases can be contained in a smaller volume because of their characteristics. By pressing on the bottle, we reduce its volume, so the water that cannot be compressed needs new space to occupy. The air inside the object is compressed, and in this way it makes water enter. At this point, the water that enters inside the object increases its density and therefore its weight, so the object sinks. This happens because the buoyancy is smaller than the weight of the object. As soon as no more pressure is exerted on the bottle, the air returns to occupy the space it occupied at the beginning, as well as water, so the hydrostatic thrust returns to be greater than the weight of the object, that for these reasons goes up to the surface. If we want to explain Archimedes' principle, we can see some examples from our everyday life. For example, the submarine operates using the Archimedes' principle by manipulating the buoyancy. The buoyancy is controlled by the ballast tank system. A submarine resting on the surface has a positive buoyancy, so the buoyancy is higher than the weight of the submarine, which means it is less dense than the water around it and will float. At this time, the ballast tanks are mainly full of air, but to submerge, the submarine must have a negative buoyancy, so the buoyancy must be lower than the weight of the submarine. When vents of the ballast tanks are opened, seawater coming in through the flood ports forces air out the vents, and the submarine begins to sink. The submarine ballast tanks, now filled with seawater, is denser than the surrounding water. Now the submarine can obtain neutral buoyancy, so the buoyancy is equal to the weight and the submarine stays in the same position. To make the submarine rise again, compressed air is simply blown into the tanks, forcing the seawater out. The submarine gains positive buoyancy and becomes less dense than the water and rises up.
Archimedes' law also explains why Titanic has sunk. According to the Archimedes' principle, The behavior of a solid immersed in a liquid depends on two elements: its weight, which acts from top to bottom, and the hydrostatic thrust, equal to the weight of the liquid moved by the body, which acts from bottom to top. Therefore, so that a body float, it is sufficient that, immersed, move a quantity of water with a weight equal to or greater than its own. The principle demonstrated by Archimedes is exactly what happens with ships. These large structures, thanks to their shape, move enormous quantities of water and receive a sufficient boost to allow them to float. It is clear, however, that being afloat also depends on certain factors, such as the density of the materials, that is, the ratio between its weight and volume. The ship is made of dense materials, such as iron, but inside it contains hollow areas full of air, which allow the density to stay below that of the water and allow it to float. It is important that even when the ship is loaded, it does not exceed the weight of the moving water and that there is no leak in the hull and no water embarkation. Titanic, therefore, as soon as it was filled with water added to the weight of the hardware, became denser than the water itself and sank. Another event, similar to the experiment fish in the bottle, occurs in fish. Most fish are equipped with a special organ, the swim bladder, placed above the intestine with which they control their hydrostatic thrust. It is a sort of inner tube that can be filled with different amounts of air. By increasing or decreasing in volume, it allows the fish to vary its hydrostatic thrust to make it greater, equal, or less than its weight, depending on whether the fish wants to rise, float, or descend. This means that the fish can be stationed at the desired depth.
Friends, my name is Arja. It is 13 years old.
Hello friends, my name is Efe. It is 13 years old. Today we are going to take on experiments. Video about density materials. Two tangerines, two glasses of water. Firstly, we peel off the tangerines. Then we throw the tangerines into the water because the tangerines is pellet, or because the pellet tangerines is more than the water densely,
But the less tangerine is less water than the weather. Thank you for watching, your friends. Hope that your friends into to give you information about density in this experiment.
See you.
See you.